All right, so we are going to continue our conversation, exploration of domain and range as far as looking at piecewise functions. So the other day in class, we were talking about domain and range, and we were looking at some inequalities, so trying to determine the domain and the range of different types of functions. And then I use this little graphic to help kind of visually represent what we're talking about with domain and range. So domain, remember, that's the set of all of your x values. I use the book of domains here because, if you're going to read a book, how would you read a book? That's going to be left to right. So when you're looking at a function that's on a graph, whether it's a normal function or a piecewise function, you're always going to read the domain from left to right. Same thing with your range. It's a set of all your y values. So think of a mountain range, right? How would you climb a mountain? You would start at the bottom and work your way up. You can't start at the top and go down. That's not climbing a mountain. That's cheating. So that's domain and range. A little reminder is that we also have interval notation as well. So when you have open circles or if you have arrows at the end, you're going to use parentheses. The arrows are signifying that it's going to keep going in that one direction. So it's headed off to either positive infinity or negative infinity. But if you have closed dots, that's when you use that hard bracket there on the end, because it says that like it ends at that point. I know that point exists within my domain or within my range. And then if there are gaps, you're going to include the U like you would normally have. So like as an example, if I had this inequality here that was graphed, I have 5 and 9. Let's say this is a closed dot, this is an open circle, I'm shaded here and here. So I have like x is less than 5 and x is greater than or equal to 9. My interval notation for this is negative infinity to 5 and then 9 to positive infinity. And because there's that gap there, I'm going to use this union symbol to show like there's a little gap space here in between those two, and that's what this is signifying. All right, so let's look at a couple graphs here. Now, for our domain and range, remember I showed you this yesterday or the other day in class that I try to do, well, first, I extend my graphs a little bit. So I'll go whoop and up this way. And the reason that I do that is because if I'm going to highlight my domain, my farthest left to my farthest right, well, all the way off the side here is negative infinity and positive infinity. So my domain for this graph, negative infinity to positive infinity. And then the same thing happens with my range, because if I go bottom to top, because there are arrows at the ends of this, that's negative infinity down there and positive infinity up here, it is also negative infinity to positive infinity. This one has a domain and range of all numbers that you could possibly think of. Now for the second graph here, there are arrows at the end. They're like, big old arrows. So they're pointing off this way and this way. You can extend them off the graph if you want. The thing here with your domain is that even though it's going down and it's not going down very quickly, it will eventually like keep going out and out and out that way. So your farthest left point, if you're thinking about your domain, is off in the negative infinities, right? It's going to keep going down and to the left off to negative infinity for your x values. And then same thing for your farthest right point, is that it's going to go down and to the right, so it's going to keep growing to positive infinity on the x, so that goes from negative infinity to infinity. Now, for the range, your bottom, there is no bottom. It's going to keep going down and down and down, so that's obviously at negative infinity. And then the top part, it actually tops off here at 4, right? You can follow that across. So it tops off at 4, and you want to put a bracket on it. Reason being is that this is not an open circle here, it's a closed dot. It's just not very visual. Like, I can put a coordinate point at each one of these spots. I can even put coordinate points in between for not whole coordinate points. So if it's a closed line there, it's always going to be a hard bracket. So our range, negative infinity to 4. For this graph, again, let's think, I'll extend this out. It's going to go down and down and down and left and left and left. So it's going to keep going in that direction, which is negative infinity over there. And this is going to keep going up and up and up and to the right and to the right. I'm over exaggerating how much that's going to turn there. Like, it's going to go up faster than it would be going to the right, but it's still growing off to a positive infinity on the x. So my domain is negative infinity to infinity. And then the same thing with my range. It's going down and it's going up very quickly. So those arrows being at the end, right, this is going down fast. This is going up fast. So it is also negative infinity to infinity. My pencil's giving me weird infinity symbols this morning. Now, this semicircle here, let's figure this out. Domain, farthest left to farthest right. So my farthest left is negative 4. My farthest right is positive 4. And there are brackets on both those ends there, right? It ends at that point. There is a point there. If it was an open circle, then we would have parentheses. Now my range, the bottom being here, and my top being up here, it ends at the x-axis, so it's not going down. So the bottom part of my graph is 0, and the top part is up there at 4. And both of those are also brackets because there are no open circles within this graph. This one doesn't have a domain and range line, so I'll just kind of write them in here. Domain, so for domain, we're thinking farthest left to farthest right. Now this arrow at the end is going to keep going up and to the right, so positive infinity over here. So it stops at this point, negative 5, and that's a bracket because it was a closed dot there. And then it's going to grow to positive infinity on the x. So our domain is bracket negative 5 to infinity. Our range, think bottom to top. The only part with the top is that if this arrow is going up, it's going up slowly, but it is going to eventually get all the way up there to positive infinity. It'll just take a long time. Like, again, I'm exaggerating the growth in that it wouldn't curve like that. It would keep going in a straight line. I just don't have enough space here to show you how far it would go to get up to infinity. So it is growing to a positive infinity on the y. So we go from negative 2 to positive infinity. And then 12, it's a similar one to one that we just looked at a little bit earlier. Our domain, think if this is my arrows at the end, it's going up, but it's also going to the left. I'm exaggerating with that curve there. It wouldn't curve, but I'm showing it's got to go all that way. And then same thing with this right side here. It's going to grow, and it's going to eventually get to that positive infinity on the x. And then negative infinity. So my domain, negative infinity to infinity. My range, think bottom, so that's here, to top, it grew off the graph, which was in positive infinity. So we're at -2 to infinity. -2 as a bracket. Infinity has a parenthesis. So all of these are pretty standard functions that you've probably come across in Algebra 1. Now let's start looking at some piecewise function. Oh, there was my domain and range part. So here, as we're looking at piecewise functions, the reason it's a piecewise is because there's multiple different equations within here that are making up this graph. So I've got like this part here and this part here. Now, when we are doing domain and range, let's just focus on domain first. So it's all of your x values. So I'm scanning this graph from left to right, trying to figure out all of the values of x that are covered here. Now this arrow is going down, and it's going to keep going down, and it's also going to keep going to the left, which is -infinity. So that's where my domain starts, -infinity. And then it comes all the way up here to, we'll call this -3. And this is an open circle here. So I'm going to leave that as a parenthesis. So that's that first part. This is covered by -infinity to 3. But then there's like this big old jump here. There's like all this space here that's like just kind of there. But it jumps up to this point up here, which on the x is -3. And it's going to keep going this way, down and to the right, growing to positive infinity. Now, this point up top here, this is the coordinate point, -3, 7 up there. This is a closed dot, so that means this second part of my domain gets a bracket. And like we mentioned earlier with interval notation, there's that big gap there. So I'm going to cover it. Actually, I'm doing this incorrectly. Silly me, I'm getting ahead of myself. The reason that I'm backtracking here is because when we're thinking about what's covered on the x, and this is a mistake that even students commonly make, I can make it too, it's covering all of my x values, right? Even though there's a gap here, it still jumps straight up to this 3, and then it keeps going down. So all of my x values are covered from -infinity to positive infinity. I was ahead of myself. Now we're going to look at the range, the y values, and that will make more sense as to what I was doing there. So my range, bottom to top, there is a bottom here. It's at -infinity. So my graph, the lowest part is -infinity, and think it's going up and up and up and up. And then there's like this gap here between these points, but because this is still covered here, like this graph, it like jumps up here and then comes back down. So I still have everything covered, but it just tops off at 7. And that would be a bracket. So all of my points are covered. I've used something called like a function scanner before. I'll just draw this example and move it. So think if I am moving this line and I'm like scanning it, if I ever hit a point where it's not covered on my range, I have to say, okay, there's a gap there. So that works from -infinity up to 7 there. I could also rotate this scanner, and if I did it on the x, it's like, all right, everything's being covered because it's an arrow going down. Yeah, there's a gap there, but it jumps straight up, and then it's coming straight down that way. So I'm going to leave my scanner off there, and we're going to keep using that. Now this piecewise function for our domain, oops, made it too big. Our domain, I don't need the D there. We're covering, here is my farthest left point, So that's -5. And let's use this scanner. So it scans and it's like, okay, I've got all these points. And then it stops right there because there's this like gap in the middle between that point and 2. So we're going from -5 to 1. And there will be brackets on both of those. And this like gap here is not covered. So that's where the union comes into play. And then my scanner picks back up, and it's like, okay, so we're starting back at 2, and I keep scanning that way, and I end at 5. So after the jump there, it goes from 2 to 5. Let's rotate our scanner so that way we could do the Y's here. So the Y's, the lowest point, it's at -2. That's the bottom of my graph there. So let's move our scanner. So far so good, it's got everything covered. Yes, there's a gap there, but I'm still covering here. Notice that it's still being covered on that point there. So my scanner goes up and it tops off here at 4. So my lowest point was 2, my highest point was 4. Let's keep our scanner moving with us. Move it into the next problem here. All right, another piecewise function. There's some gaps. Let's cover the domain first. So let's move our scanner. Like, okay, so -infinity is where it's starting. It's coming here. I notice that there's a gap there, but it picks it right back up there. So there's no stop in our graph. Again, another gap, but it picks it right back up there. So notice that we never had a stoppage in our domain. So we're from -infinity to infinity. Both of these being closed dots here. I know they kind of look like open circles, but they're closed. Now let's flip this and make our range scanner. So the bottom of our graph is down here at -2. And let's move this. So -2, we're going up. There's a little gap there, but it's okay because it's still covered. And notice there's like this gap here in between these two, but this part of this piece of the function still has it covered for us. So we're going to keep it moving, and it's going to grow up to +infinity. And the bottom has a bracket at -2. Let's cover one more here, maybe 2. All right, so scan the left to the right. If I scan all this, yes, the arrow only stops there, but as far as domain, it's going to keep going down and to the left. So we are starting with -infinity. And then as this moves, there's a little jump there, but it's still covered on the x-axis, so I'm okay. So it scans and it scans, and it's going to keep going off into that direction. So -infinity to +infinity. Now let's move this. I'll rotate it to make it our Y scanner again. So from the bottom, we're covering up here, and then we get to that gap there. So our lowest point, -infinity, and it comes all the way up to 0, but there's an open circle there, and then there's this gap. There's this gap here where all of these Y values are not being covered. So that's where I need to throw in the U there, because our graph picks back up at 1, so at 1, and it's going to grow up to +infinity. So we're going 1 to +infinity, and that 1, because it's a closed dot, has a bracket on the end. I think we have, there are 2 more problems here. you have this note packet, so why don't you try these two first on your own. Pause the video here and I will go over the answers. So pause this, try to get your domain and range first, check yourself, and then see where we're at. All right, so you paused your video, you found your domain and range. Let's double check that you got these right. So I'm gonna use my scanner here. I'm going farthest left to farthest right. So notice that there's no break in the action there for domain. So negative infinity to infinity. Now for my range, let's rotate this guy from the bottom, starting at 0. And it is going to keep going up and up and up and up and up. So it goes up to positive infinity. 0 is a bracket, infinity is a parenthesis. Now, 18, little strange, but we're going to go over it. So, domain, cover left to right, scanning. So far, we're still touching all of our lines there. All right, so we covered everything for a domain. So again, a negative infinity to infinity. It's pretty common that you have that as one of your domains or one of your ranges. Now, for the range, from the bottom part, notice that it's just a horizontal line there at negative, what is that point? Negative 4. So that's the bottom of my graph, but it's like just covering itself. And then there's this gap here where all of these points are not covered. Like my scanner doesn't work in this area, but then it picks back up at 1, which is an open circle, so it's a parenthesis. And then our scanner is going to keep going up and up and up and up to positive infinity. And because there was that gap, you get a little U there. So it's a weird part because you're still covering negative 4, but it's just the value of negative 4. And then you jump up to 1 to positive infinity. So there's your domain and range. So follow along in your notes packet. Hopefully this answered some questions for you. We will practice this more in class, and then you can work on your homework.